Well, hello, everyone. This is William Hadala. Welcome to the Watt Hour. And today we're going to be diving into the frontier of space and enabled infrastructure. And our guest is the founder and CEO of Space Copy, which is a startup dramatically reimagining manufacturing in extreme environments from the Arctic to the lunar surface. So please welcome me and welcoming Madison Feehan to the show. How are you?
I am fantastic. Thank you so much for having me on today.
You're welcome. I'm really excited about this topic, and it's awesome to see that you're leading in this space. So, Madison, let's just cut the fluff. You're building what could be the industrial backbone of off-world and disaster zone manufacturing. Tell us what space copy actually is in simple terms, please.
Yeah, of course. So I like to say in situ logistics and additive manufacturing, but that's not layman's terms. So basically, I would characterize our work as 3D printing in the most extreme and austere environments known to man and Earth and space. And that's basically deploying 3D printers onto the front lines and operating in your extreme climates like your Arctic, your desert, subsea, rural communities, all the way up to microgravity in the lunar surface. So basically, anywhere that you are, you're in a remote environment, you don't have access to standard supply chains. We build 3D printers that could be deployed on site to take local materials like soil and sand and scrap metal and turn that into repairable infrastructure.
That's awesome. So you're targeting everything from lunar regolith into infrastructure for Artemis missions and to remote military or disaster response scenarios. Is that genuine versatility or stretching your tech too thin before it's proven? And what can it already do today?
That's a question that I ask myself a lot as a founder. So we just celebrated our third anniversary. We've been profiling this tech for a good long while now. I started the research on it back in 2017, and then we incorporated back in 2022. Um, we are at TRL 4 right now. So the way that I look at the tech is we've done enough in-lab work to validate that the concept works. We've used regolith simulant, your off-the-shelf stuff, but we've also developed out some things that are customized to be similar to the lunar South Pole. We've worked with Arctic rock, we've worked with volcanic soil. We were doing it mostly under, your standard lab ambient conditions, so it's not going out into the field and plowing away what's -40 outside. But it is enough of an indicator that we were able to 3D print successful repair parts and bricks and tiles and cylinders. So I say that we have the capabilities, and now we are optimizing and integrating so that we can get into the field by early next year.
Fantastic. And so, as you said, your TRL, MRL4, patent pending and early prototyping, that's serious tech, very early stage. So, yeah, how much of this is functioning hardware versus slides and software demos?
Right now, we have a prototype that is in the works. The fun thing is that we integrate a little bit of COTS hardware as well. So when I say TRL 4, I mean overall system TRL 4, and that includes both the software and the hardware components. But if you break that down, we have equipment that processes or beneficiates the materials, a more tech term for it. And that's already well above like a TRL 7 or 8. And then we have our 3D printing hardware and our secret sauce that's more closer down to that TRL 4. And then we have robotic post processing equipment that, again, is a higher TRL. So when I kind of characterize that, there's a bunch of equipment that is ready to deploy. And we kind of look at it as like a plug and play. The end user will fill in an intake form, whatever they really need, and then we will assemble accordingly. So, in the broader scheme of things, there's a whole bunch of that is already validated and provable and ready to deploy. But at the same time, the actual integration process, we're building a digital twin to test it in these extreme environments before we get out into the field. That part still needs a little bit of tweaking, and that's what we're focused our energy on right now.
That's great. I say that a lot is that I'd rather innovate than invent, make versus buy. So it's good to see that you're integrating commercially off the shelf technologies into the newer tech that you're developing. So the homepage notes on your website that you kicked off a seed round January 1st, 2025, aiming for 5 million with NASA and a renowned VC firm already on your board. Has the round closed and who else is in, or are you still shopping for partners?
We are definitely still shopping. Things are progressing really nicely. So we didn't really publicize the pre-seed round very much. We were testing the waters and just seeing if we could make things work with the private equity side of things. But there will be an announcement coming soon about that closure, and then the seed round is still ongoing. So we have a lot of things in due diligence right now. We're really excited about the way that things are shaping up. Of course, this this kind of market right now for raising capital is never really a fun time, but we've been doing surprisingly well, and I credit that a lot to our team and our traction. But 110% if you're coming at this from industry, government, or academia, or not academia, sorry, like from industry, and you're looking to partner, you have a venture arm, et cetera, that's definitely something that we're looking for.
So, talk about the competitive landscape here. Like, who else is doing something similar to what you're doing? And when if you look at, who's leading the race, can you talk a little bit about others that are doing this and what differentiates yourself?
The fun part is when you really sit and characterize it, there's not a lot of people that I consider to be similar. There's people playing in the league of manufacturing for extreme environments, definitely. But then when I compare our tech and I look at their tech, we're hitting different niches. From a broader stroke of things, there's like the guys at Icon, who are pioneering some space-based manufacturing. There's a company in Australia called XSpeed that's working on defense front lines as well. So there's a couple key players that are trying to develop out the tech. I like to use the term competimates as opposed to competitors because the industry is still relatively novel, deploying 3D printers into combat zones or natural disaster sites or space. That it's an early enough market that we're all still trying to understand the ebbs and flows of how this works. So we have the liberty of saying that we are kind of more like working together to solve a unified challenge as opposed to really competing with each other. Um, but circling back to that thought a little bit further, if I was to pinpoint some of our value proposition at Space Copy, I would primarily delineate that as the fact that we have super modular, highly customizable system. You can get it in a desktop format, so about the size of your laptop, all the way up to something that prints a cubic meter in size. So they vary greatly in their modularity and their size capacity. But moreover than that, it is the ability to process multiple materials and 3D print them in one mechanism without actually having to change over specific hardware. It's done autonomously. It has mineral identification technology integrated into the printer so that if you're working with a thermoplastic, a carbon fiber, a metal, or a ceramic base like regolith or sand, that you're able to differentiate what kind of process parameters you need to 3D print with without actually having to make a physical adjustment to the printer itself. Um, we follow that up with automated post-processing and quality assurance, and that is just not something that I've seen done in an enclosed, looped cycle. I feel like that takes a lot of different pieces of individual equipment, and our goal is to be able to deploy one single piece of hardware that, again, can be dragged and dropped into those ecosystems. So that's my trail of value proposition is just the ability to do all of that in one step.
And I like what you said about cooperation or competition, correct? Like working with others. We're really at a point, especially with space. It's funny that we want to become interplanetary, beings, but yet we can't figure out how to get along with each other here on Earth. But let alone how do we work together with each other and how do we complement each other and what it is that we're doing. So you founded Space Copy in 2022 and you bring a hybrid skill set. from advanced lunar instrument development for NASA, alongside business and entrepreneurship training. What gave you the confidence that this mission was actually doable?
So I worked for NASA for about 6 years. I was their everything person. They kind of threw me around from department to department, filling in gaps, and for me, that was fantastic because as an early career professional with no real technical experience, that gave me such a great grounding opportunity to dive into so many like, just sub-disciplines. So I was working everywhere from planetary science to heliophysics and astrophysics, and a lot of our work had to do with either data analytics or dual use hardware that could be deployed into extreme Earth or space environments. So it comes full circle. Um, there's something special about being the youngest person in the room because you get so much great mentorship early on. And it was a big challenge. It was a good opportunity to kind of just, find your fit, figure out, what do you really need to do to compete in this industry. And it was difficult, but it was really rewarding. So I took a lot of those skills. My background's in business. Got a certification program from Harvard. I'm wrapping up an international business degree right now, and then stepping into graduate. Um, I kind of combined all of those skills from academia to work experience. I contracted with the European Space Agency for a short amount of time and did a lot of volunteer work in the space industry as well. And I was seeing all these different inputs that said there's a lack of resources, there's a lack of capacity when you're working in extreme environments. It came to me um, originally as just a concept idea back in 2017 of what would it be like to send humans to Mars and how would they sustain themselves through habitation and other means. And 3D printing for me was something that I just had picked up as a bit of a hobby to research. But then working at NASA and getting the hands-on, I was seeing the words 3D printing and additive, coming up a lot. And then 2023 came around and the Planetary Decadal Survey was released. And then the ISRU Market Gap report was released about the same time, and they were talking about all these in situ resources and how we can use space debris and regolith and localized materials to create infrastructure. And then more recently, last about this time last year, the civil space shortfalls report came out, and additive manufacturing was named the top 30 technology gap. So that's from the space side. You'd pivot that idea back over to defense, and the DoD has a whole additive manufacturing strategy guideline. They have budgets, they have departments and facilities and warehouses worth of people that have been researching this tech for decades. 3D printing is already used in active military service, but it's used in a, I wanna say, slightly disadvantaged capacity where you're having to consistently supply metals and plastics and filaments and powders to keep these things running, and nobody really knows how to use them. So I was seeing all these inputs saying either we're using it or we wanna use it, but not a lot of training and understanding around capabilities and how to use it in those especially austere climates, which is where I find that especially at Space Copy, our vision of development is to really, really focus on the places where it can be utilized the most. That's the front lines.
That's great. I love that you have that ability to see where the gaps are and then be able to insert technology, pivot, and do it quickly. And so, manufacturing on the moon or in a disaster zone, that may seem really like ridiculous to some people in a good way. Um, where are you hitting friction? Is it regulatory or supply chain or materials, scale, or proving it can survive a real, pardon the pun, but like a real snowstorm?
Is there a little checklist at the bottom of that where I can just check all of the above?
Yes, there you go.
Because it is a little bit of all of those things. It's, having to go out there and chase your ISO certifications and just get so much clearance and really get into the heart of things. I was a government contractor, I was a non-civil servant, so I understand it through a different lens. I understand the review process and what it takes to have a winning piece of tech. But then to go out and actually build the tech and build the business and try to infiltrate those federal agencies through that lens, again, it's a different kind of context. So I think for us, it's just the hurdle and gap. I'm Canadian also, which is we're still part of Five Eyes, but it's another slight regulatory hurdle. Aside from regulatory, there is the whole tech validation bit, which I think that you touched upon a little bit earlier in today's conversation. It's fine to build something and prove it out in the lab, and you need to do that as a necessity. But getting out into the field, and again, that's our focus for 2026. We have 3 pilot demos planned. Um, Making sure that it works in a blizzard or a sandstorm is going to be absolutely fundamental. So, us getting to Leo and us getting to the Arctic are our top goals over the next 12 to 18 months, as well as doing a more traditional pilot project, just, inside a nice warehouse facility for a client in aviation. There's a lot of different possibility, but I would say that proving out that tech is what's really gonna help us unlock the next stage, and that's raising more capital and exiting that survival stage and starting to move into the scaling stage of the company. And the tough thing about hardware, I mean, it's not 2021 anymore, you can't raise capital on a napkin idea, is you really have to go out and you have to win contracts, or you have to build the tech all the way past TRL 6 as a unified system before people will get to the point where they're taking you seriously. So I'd say it's those hurdles that we prioritize the most, and then probably a dozen or so other things that kind of fall into the line afterwards as a result of that.
It's sometimes just being at the right place at the right time and having the right audience and doors open when they're meant to be open and not before and what have you. And so, are you an IP first entity selling licensing, or is it going to be hardware unit sales or a service play? And who's your first paying customers supposed to be? Is it going to be a space agency, or is it going to be a disaster relief organization or military? What are your thoughts there?
I mean, I feel like defense has the bigger budget right now, just the way that the federal government is shaping up. So I think that we would like to really start targeting that direction. That said, the way that we're targeting this right now is we offer different service and sale platforms. We have your traditional hardware sales. And again, I was kind of referencing, you take an intake form, you plug and play what pieces of hardware you really need, and we build out a customized system around what materials you'll be printing with, where you'll be printing it. Do you need advanced mineral identification hardware, or do you just need a printer and a robotic arm? Um, so that in itself is a whole revenue model, and it's probably going to be our biggest target. But we also have something called 3DAS or 3D SaaS, where essentially we are providing the printing as a service, especially to early customers that are trying to get a feel for the tech and understand if this is something that they want to use and they want to work with on a regular basis. So we kind of use that as a validation tool. It works especially well for small to medium sized businesses as well. And then we have gone down the pathway of licensing agreements. We're not turned off to it. But as an I do agree with the term IP first, as an IP first organization. And especially as a woman owned small disadvantaged business, you have to be careful. And licensing does open up potential to risk. And I've seen it happen with other manufacturing companies. You don't want to give away too much of the secret sauce. So if I was to imagine where we'd be 5 years from now, it's gonna be really focused on that 3 DAS and the actual hardware sales, probably 70% B2B and 30% B2G with a focus on defense and disaster recovery. And then as we start to get into the 5 to 10-year plan, really, really focusing on space and transitioning any of the government work that we're doing with NASA, for example, and transitioning that over into something that is more like a traditional service agreement or a purchase agreement. Now we've got a Space Act agreement that's pending, and we have a whole bunch of champions within government agencies that are helping us along this pathway. But making that transition from research into more traditional sales is something that we're looking forward to, even though we know that it's still a few years away.
Yeah, we recently started working with the University of Texas, El Paso with Nathaniel Charles Groups, which has spun up a new national defense aerospace space unit. We met him at a Space Force at an event in Los Angeles, and the Space Force is finally listening for space domain awareness that we need to have edge computing in orbit. In order to support edge computing, we're going to need advanced satellite buses to power that edge computing, and we're going to need new sensors and payloads. While at the same time, there's a group called Space Safari and
Yeah.
something called tactical response space, right? How do we get things in space very quickly within a 72-hour period? But I was at El Paso last week and touring their facilities, and they're doing some amazing things with additive manufacturing, nowhere along the lines of what you're doing. They're using exotic metals, but the ability to containerize not only energy storage around containerized edge computing, but the ability to have containerized additive manufacturing using the elements that we may deploy them with the army and others. And if you look at Ukraine right now, they've gone through so many drones, unfortunately, in such a short period of time. There's a German manufacturer that realized I can make these drones quickly using
Yeah.
wood drones to deploy. To your point, right? What are the materials available in forward operating bases or in theater to make that happen? So I'm excited to bring you into that with us to make those relationships because, like, tactical response is a contract vehicle, within itself, where they're looking to deploy this technology very quickly. So if you look at the next big thing or milestone, let's get through the terrestrial testing and like a lunar demo. I love to do a lunar demo as well because this space domain awareness is going to require some advanced things into orbit and not necessarily things that passengers have to ride on. So I've been joking with my team, just get me a Gemini or an Apollo capsule. It doesn't have to be Orion. Let us retrofit it, while Vast and SpaceX are doing their great things, but it's a little bit longer off. So, what's the next big deal here? Is it to just really execute your on the ground customers and then do these lunar demos or better yet, low Earth orbit demos? So, and what's your timeline beyond these three demos that you're going to be doing next year to prove out the technology in Arctic and exterior environments?
110%. I think that we should validate the tech terrestrially before we start stepping into the bounds of space. Because once you cross the Kármán line, there's a little bit of an expectation that you deliver something that works. Um, Us getting into the Arctic, I think, is going to be a big milestone for us. And we're going to be working at an impact crater site. So it's still space adjacent. There's still a lot of astronaut training that goes on within the area. So it's pretty much as close to simulated space as you can get for an analog site while still being in a relatively austere climate. It's nice because it's also located next to a lot of rural communities and indigenous communities. So we have an opportunity to provide construction relief to otherwise underprivileged folks, which for me is a nice giving back opportunity. But aside from that too, there's the huge defense capacity, put it in a shipping container and send it off to the Philippines or send it off to Ukraine, of course. Um, Something interesting that you touched on was drones. We are running two joint venture projects right now out of Europe. One is going to be dedicated to more of like a space-based side of things. And then one is going to be dedicated more to defense. And one of those incumbents is to be able to manufacture repair parts and rapidly assembled drones for being able to deliver things like medical supplies into disaster sites and combat zones, amongst a whole slew of different use cases and opportunities. So these are all things that we're looking at. We can 3D print over 250 different repair parts and precision tools and anything up to a meter in size. So that opens us up to a pretty wide lens. Right now, again, especially over the next 12 to 18 months, really focus in on getting to a couple of end users, getting to, for example, I mentioned a client in aviation. We focus on energy, we focus on mining, we focus on space, we focus on defense. We have ties across Europe, Middle East, North America, so being able to gauge everybody's interests, do a lot of customer discovery after the prototype, and then get up to those 3 pilot demos. Um, while that's all running in the background, we'd love to get into Leo and just do a test demonstration, and we have a couple of different launch agreements that we're playing around with and just seeing if there's something that we're comfortable with and making sure that timelines align so that we're not jumping the gun too soon. But we want to get onto the lunar surface by 2031, and we have a really great established framework to make it happen. But again, small steps mean larger steps for the future. So let's start by getting to the Arctic and build from there.
Yeah, and it's, you know, when you start thinking about a lot of the thought leadership around putting humans in space and the long-term effects of not having gravity, and even to the point where they're saying, how sustainable is it to have humans on Mars? And how do we overcome those challenges? The one thing I do know that we'll be able to do successfully as a species once we figure out the artificial gravity and dealing with radiation and what have you, which will come in time, is robots.
Yes.
Robots will be happy representing humanity on the moon, in orbit, on Mars. But in order to have that type of robotic infrastructure, you would think we need to start building that out in these remote areas of our planet, whether it be Arctic or in theater, and in eliminating the need for humans to be involved, especially when it comes to saving lives or protecting lives. I mean, it's unfortunate. I mean, I don't think we're going to head into a Terminator type of world where AI is going to take control, but we are heading into a robotic military point of world, and those robots are going to need to eat batteries. They're going to need to repair themselves. They're going to need to be able to, make themselves, replicate themselves in the structures that they live in, which I would think one day humans would habitat or live within. So when you think about it from that perspective, and I think, let's just think like, 10, 20 years from now, and maybe we still haven't overcome some of the challenges of radiation and long-term space life for humans. How do you see this technology evolving, and how do you see perhaps the representation of humanity through robotics, whether we can upload our consciousness into robotics one day or not? I personally would love to live to about 200 years, and then
Yep.
I'm done. I think I'm done. I'm ready to go on. But how do you see this all unfolding, and think generationally, maybe the next 20, 50, and 100 years? Where is this all going to go?
I mean, look at the world 100 years ago compared to now, and it's unreal the way that we've advanced technology. Um, I love that you asked this question. Um, I don't want to put too much limelight on what somebody like Elon Musk is doing. He does have some pretty good ideas, though. I mean, when you look at the architecture of getting to Mars, for example, I want to say that's like within the 50-year timeline for sure, right? Assuming that's the case, a lot of what you just touched on is true. You're going to need robots. You're going to need autonomous vehicles that are powered by battery as opposed to traditional fossil fuels. You're going to need mining because of radiation exposure. It's a natural given that there's a pretty good odd that most of the capacity for infrastructure development will be done underground. Like the way that lava tube designs are being looked at on the lunar surface is, I think it's easily translatable to working and living as an interplanetary species. So the same prophecy goes for Mars, and then you look at things like Elon, the Boring Company, and Tesla with the non-traditional vehicles and the robot systems that are being developed out. You just see where everything starts to kind of fall into place. Um, there's many companies and many thought leaders that are working to pioneer the way that we look at generational technology advancement, especially for long duration space missions. And I see us heading towards an AI-based, robotics-based future where we are using these things as reconnaissance tools to be able to get the lay of the land before we deploy human life. So we're doing it, I'd like to say, a little bit smarter than the Apollo missions, right? Um, Within that same context, regulatory hurdles and being able to actually have a solid control over what your AI and what your robotic systems are doing, I think is going to be paramount. And international governing bodies are really going to have to step in and make definitive choices because we've got things like the Artemis Accords, but they're overlapping with the Outer Space Treaty and the Moon Agreement. And now nobody can decide how they're living and working in space. And you have all this conflict with the second space race. So we're talking about, building all this futuristic tech, but we still have combats. We still have a disagreement on how we're going to populate extraterrestrial bodies and do long duration space flight. Um, the way I look at it with space copy is we're building something that's going to be versatile over generations. We're always going to need to repair things. There's always going to be remote ecosystems, whether that's on Earth or off planet. Um, and when we get to the point of being able to really have humans doing long duration spaceflight missions, we have to be conscious of the astrobiology component in this as well. And right now we're finalists for the Bohr-Young's Human in Space Challenge, and what we're pioneering with that is being able to 3D print a moisture wicking and radiation resistant textile that could be used as insulation for habitation in spacesuits. So look at space copying. We're not just creating your nuts and bolts and your socket wrenches and that, but we're creating things that are going to have a long lasting impact on the way that we expand, the way that we work in austere climates. So in a broad answer to your question, I see that the way that the tech is developing currently and the way that we've developed over the last 100 years, and I can see that we're going to boom in that direction. We need to be careful how we do it. We need to be methodical and thoughtful of that. And then, moreover, at Space Copy, we just need to make sure that we're keeping up with the times and that we're validating the tech and getting out into those ecosystems because we know we have the use case. We just really need to align some of the finer tuned mechanics of it.
Yeah, I think about John Glenn going into space at a latter age, as well as William Shatner and others. And with commercialization of space, I know that when these advanced batteries and edge computing goes up there, I may not do it on a NASA route, but if there's a means and a way to be up in orbit to work on these systems, I will be the front in line. But to you, I ask that question. I mean, are there aspirations on your end to become an astronaut or something along those lines?
I mean, the training sounds a little bit intense, but I think the better alternative, and people that know me know that my tagline is "Future Billionaire." How about I just build a big company, right? And then I just pay for a quick little space tourist mission. That could be a good enough solution to me. But yes, I would love to go to space. I would love to be able to demonstrate my own technology in microgravity, or even better on the lunar surface. So it's a distant aspiration of mine, and I don't think that you can work in space for too long without catching that bug.
Yep. So for two future tech billionaires, maybe trillionaires here, maybe that joint mission will fund ourselves to make sure your printers are working with the robotics on the batteries, even though it might be a short period of time. So, Madison, thank you for keeping this grounded but ambitious. And Space Copy is tacking from many dismiss as space science fiction, but your traction shows that you're serious for those watching. And you can follow Space Copy's journey and connect with Madison via their website. And so, can you give us a little bit of how we get in contact with you if somebody wants to talk to you?
Yeah, come in the masses, people. You can visit spacecopy.com. First and foremost, we have newsletters you can subscribe to. We have contact forms. You can email info@spacecopy.com if you're interested in collaboration opportunities, fundraising, joint grant projects, employment opportunities, internships. We have all of those ready to offer. And then additionally, if you want to get in touch with me, Madison Fian on LinkedIn, or you can follow at Space Copy on LinkedIn or at Space Copy Inc. on Instagram. We have a brilliant team and a brilliant board of advisors, and of course myself. We're always happy to sit down, talk with folks, and we believe in building big dreams and turning science fiction into science fact, so definitely don't hesitate to get in touch.
So that concludes this week's The Watt Hour. Thank you so much, Madison, for joining us on this show.
Thanks, William. Glad to be here.
You're welcome, ma'am, and I look forward to continuing the collaboration.
Likewise, thank you.